There's too many considerations that there didn't have the security of.
Okay. All right. Let's go ahead and get started, everyone. Thank you for attending this session. I think most of you were here for part one. If you weren't, we were covering the design goals of the release and what Microsoft hopes to achieve, and the kind of the ongoing trends in the Microsoft BI space, with corporate versus self-service BI. And so this session, we're going to get a lot more in the weeds, and we're going to run through practically the whole session is one big demo. Okay, so we're going to do a lot of MDX and DAX and compare the characteristics of the two models, and to see how they achieve sometimes the same thing but in very different ways. Okay, so excuse me, on the wrong slide. So the example I like to use is currency conversion, because it contrasts a lot of the features between multidimensional and tabular quite nicely. All right. There are different types of currency conversion out there. The most common form of currency conversion is known as one-to-many currency conversion, because you store all your transactions in a single currency, but you can report them in many currencies. All right. You do that often even if the transactions actually took place in different countries. You would use the ETL to convert them to a single base currency like US dollars, and you would then use your cube or your tabular model to do the conversion to get to the reporting currencies. Unless you've really got a requirement to store your transactions in different currencies, I think one-to-many is the best way to go, where you store it in one currency, because that means that there's less work and less calculations that you have to do in the cube or the tabular model. The ETL is there for a reason. I think it's an incorrect statement to say that we should always do calculations in the cube or in the tabular model. I've been using cubes for many years, and I actually enjoy writing MDX. Many people don't, but if you can do a calculation in the ETL without causing a data explosion problem, and also without introducing significant complexity to your model, you should really be doing it in the ETL. That's what your data warehouse is there for. That means that there's a bunch of other consumers that may need a SQL interface, like for applications. They can leverage that business logic. The lower down you push the business logic, the more reusable it is, which is just the best practice. And that's the whole principle of a data warehouse, is that it's done a lot of the work ahead of time, so the queries are just going to perform better. But then again, there are some calculations that are just born to be done in the cube or the tabular model, which is aggregated level type calculations. Right? There's some calculations that would cause a major data explosion problem for you to try and do them at the relational level. So again, as a best practice, if you can do it in the ETL and encapsulate all of those calculations in your kind of business, below your business-oriented model, then you should do that as your data warehouse model. But then there's a bunch of calculations that you have to do in the cube or the tabular model. In this case, we're storing the base currencies in a single, the base transactions in a single currency, US dollars, but we're going to use the cube or the tabular model to convert those values to reporting currencies. All right. So, as I said, we're going to store the cells in a single transaction, or sorry, in a single currency, and for each transaction there is obviously a date, right? And then for each date there are going to be multiple conversion rates, one for each date. So it's one for each currency. Let me say that again. For each date there are going to be multiple conversion rates, one for each currency, right? And similarly, for each currency there are going to be multiple conversion rates, one for each date, because the conversion rates change over time for each currency. So the correct kind of level of granularity to model this is with a many-to-many mapping table between date and currency. Right? So here's some base data, and we want to report that same base data to other currencies. Right? So obviously these numbers don't look correct, but the reason I'm including this is that this is the default behavior of many-to-many dimensions in multidimensional. where as long as there's data in the many-to-many mapping table, it will just repeat the value for each of the members of the outer dimension or of currency, right? And the reason I'm including this is that there are many cases where this is exactly what you would want, where you don't want to apply an allocation or a conversion to the data. So, for example, bank account balance. If you've got bank accounts with multiple account holders, you typically don't kind of proportionally allocate that balance across the account holders. You just have, for account holder A, they see 100. Account holder B sees 100 for the same account, right? You don't do any proportional split. So there are many valid business cases where this is what you want. Obviously not for currency conversion. For currency conversion, we need to store the conversion rate in the many-to-many mapping table, and then we apply the conversion, and the numbers look more realistic. Okay. Another interesting thing about currency conversion is that if we can get away with it, and I mentioned this in the first session, we'd like to not even have an all member, because it doesn't make sense. You know, your all member is normally the sum of all the child members in the hierarchy, right? It doesn't make sense to sum US dollars, British pounds, Brazilian reais. It just, you know, that's fantasy money. So we'd ideally like to not even have the all member if we can get away with it. Okay, so that's the kind of high-level requirement and the data model. So let's translate that to multidimensional and tabular and see how they would deal with them quite differently. All right. So here I have a multidimensional project, and this is part of the DSV, which, as you can see, is basically exactly the same model that we had in the PowerPoint slide. Obviously, we'd only be using one of these relationships. We're not, you know, concerned with role-playing dimensions at this time. And then for the currency dimension, we've just got one attribute in this case, and you can see this is aggregatable property. So that is aggregatable property. If you set that to false, that gets rid of the all member, right? Which we said we'd like to not have for a currency hierarchy. And then if we get rid of the all member, which is by default is the default member, so then we need to specify a different default member, right? So we need to specify, okay, I'm going to choose US dollars, which is my base currency, to be the default member of the hierarchy, right? Okay. And in the cube, in the dimension usage tab, you can see that we go from internet sales to currency based off a many-to-many dimension relationship, and it's based on the intermediate measure group of exchange rates. Okay? That's how we set up the relationship in multidimensional. A lot of this isn't even in tabular, as we're going to see in a moment, but you just deal with it differently. And the last thing I want to show here is, so the default aggregate function of a measure is sum, but in the case of conversion rates, it doesn't make sense to sum conversion rates. So the way that AdventureWorks has done it is they use the last non-empty measure, or aggregate function, sorry, and from average of children downwards, these are all known as semi-additive aggregate functions, and they will create semi-additive measures. Okay, so the classic example is inventory. If you want to create a report that shows inventory for the last 12 months, the value of inventory for each month is not going to be the sum of inventory on day 1 plus day 2 plus day 3. It's just going to typically be the last inventory value for the month, right? So it's not additive with respect to date. However, it is additive with respect to all the other dimensions. So if you wanted to sum inventory, or if you wanted to show inventory for all of the warehouses in a city, you would sum it. So it would be additive with respect to all the dimensions except date. That's why it's a semi-additive measure. Now, you could make the argument that conversion rate isn't additive at all. But I'm not going to go there. That's just the way AdventureWorks has got it, and who am I to question the AdventureWorks design, right? Okay, so we're good with that. That's how you would set it all up in multidimensional. So as you can see, we're kind of decorating the metadata of the model. And that's going to, in many cases, actually not only impact what the users see in terms of the hierarchy members, but even the actual numerical values as well, right? So let's have a look at the equivalent in tabular. And if I just open up this one over here, it closed when I did the BIS and normalizer demo in part 1, so we just have to reopen it. So you're going to see here that I've got, let's see, I've got 500 million records in there. Not a big deal, right? That's how we roll. Not a big deal. It doesn't, you know, I'm not going to cover performance optimization in any detail, but if I show you the entity relationship diagram view, so here we've got basically the same relationships set up that we saw in the multidimensional DSV. So we go from internet sales to date, and then we've got the many-to-many mapping table of currency rate, which gets to currency. And that's it. We don't go and set up the semi-additive measures. We don't. There's no capability here for setting, getting rid of the all member of a hierarchy. None of those extra features that we get in the rich multidimensional model, that we decorate the metadata of the model for those features. We don't do any of that in the tabular modeling experience. The tabular modeling experience is much simpler than multidimensional. It's just a bunch of tables and relationships, basically. Obviously, there's a little bit more to it. So a lot of that responsibility for some of those other features gets offloaded to DAX. So we said in part 1 that DAX was a query language that is more relational-like and to some extent more Excel-like. But actually, there's another key kind of responsibility or design goal of DAX, which is it assumes a lot of the responsibility for a lot of the features that in multidimensional we would have been decorating the metadata of the model with. Now it offloads a lot of that responsibility to DAX. All right, so that's another kind of design goal of the DAX language. All right, so let's look at some queries. If I connect to the multidimensional, so here I've got, actually let me switch to the other cube. So here I've got a query that gives me all of the members of the calendar dimension in 2006, and I'm showing end of day rate. And as you can see, I didn't do anything special in the MDX to get the last day in each period or anything like that. It's just built into the base measure, right? And it's got that logic built into it. And so for January 2006, the value is 1.51, which, if you remember the lost non-empty kind of design, is that it would take the last date in the period. So that's what January 31st is 1.51. Similarly for 2006, 1.42, which is the same value for December 31st, 2006. All right. So an equivalent query in DAX. Now, bear in mind, I could have written a very similar query against the tabular model using MDX. What would have been missing here is the end of day rate logic wouldn't have been built into the tabular model, so I would have had to do some custom MDX to get the last day in each period. But I could have written a similar query against the tabular model in MDX, right? Because if you remember from the first session, tabular shares a common lineage with multidimensional and has therefore inherited support for MDX, which is a big deal, which is why all the existing cube clients can connect to tabular. However, I'm going to do it in DAX, just because we're interested in it. So here I've got a DAX query that's obviously a little bit more involved in this particular case, and obviously it's going to have to do a lot more, right? Because it's going to have to take care of the last non-empty functionality. So here I've got the days in January, and the value for January is 1.51, which is the same as January 31st. Now you'll notice that I'm not using the calendar hierarchy, the user hierarchy. That's because DAX has no support for user hierarchies. You can set them up in the tabular model. In fact, the calendar hierarchy is there, right? And if I'd been writing an MDX query, I could have used it just fine. I could have used all the, the same descendants function, etc. But in DAX, DAX has no support for user hierarchy, so I have to use the columns instead. So here I've got month and date, and now I'm using this roll-up function to give me the value for the whole of January in the same result set. All right. And then, as I said, we're going to have to deal with the end of day rate logic in the query. So here it's a best practice in DAX to kind of break out your measures into components for readability and debugging. So the first measure we've got here is just the sum of currency rate, which kind of doesn't make sense. But then I'll put another wrapper on top of that one, where this is the shorthand notation for the calculate function. Right? I could have put calculate here, open bracket, end of day rate sum, and then put my calculate filters straight after it. It would have been exactly the same. This is just the shorthand notation for the calculate function, where I list an existing measure and then I say open bracket, put in the calculate filters, and then close bracket. So here the calculate function will override the filter context. So what this is going to do is it's going to inherit the existing filter context, which is going to have, for this row here, it's going to have all of the dates in January in filter context, and it's going to pick out the last non-blank date within that previous filter context, and therefore override the filter context and create a new one, right, which is just basically filtered by January 31st. All right, and that's what the last non-blank function does. And then I'm putting another measure here just for formatting, which again just is good for readability and illustrating what we're doing here with last non-blank, without there being this huge measure with, that's a bit more difficult to take in. All right, so that's the equivalent in DAX. No user hierarchies, and we're instead of decorating the metadata of the model, we're doing the logic in DAX. Let's go back to MDX land. And I've got another measure here. And this one just gives me all of the years on columns. And as you can see, year is influencing the numbers. So there's a valid relationship between the date dimension and internet sales. However, I'm listing the currency members on rows, and it's just showing me the same value for each of the currency members, right? Because I haven't applied any allocation, I haven't applied the conversion rate. And if you remember from the slides, this is exactly the behavior that we would want in many cases, and this is the default behavior of many-to-many dimensions in multidimensional. So if this was account balance being split by account holders who are holders of the same account, this is the type of behavior we would want, right? But obviously we don't want it for currency conversion, so we're going to have to apply that conversion. Now the other thing to note is I've got these nulls here. That is because Deutschmark and French francs don't have a full conversion rate data set populated in AdventureWorks. All right. So again, many-to-many dimensions in multidimensional will only show members or show values for the outer dimension if there's data in the many-to-many mapping table. So even if I were to get rid of this non-empty here, you can see that there are actually a load of other currencies in there, but they don't have any conversion rates populated at all. Right? In our account balance scenario, we obviously wouldn't want to report the same account balance for account holders that are not holders of the account. Right? So again, that's a default behavior of many-to-many dimensions in multidimensional. So let's try something similar in DAX against the tabular model. So the DAX query is quite simple. I've just got a bunch of columns filtered by each of the years. And up here, I'm showing the sum of internet sales amount and for each of the currencies. Now, on the face of it, it looks almost the same, but it's not. Because, as you can see, it's actually got, it's showing the same value for every single currency, whether there's data in the many-to-many mapping table or not. So what does this remind us of in multidimensional? This is just like ignore unrelated dimensions in multidimensional, right? In fact, this is ignore unrelated dimensions because, again, it's inherited the some of the code base from multidimensional. You could go into AMO and you could set the ignore unrelated dimensions property on a tabular model. It might give you a not supported exception, but this is actually ignore unrelated dimensions. So let me show you what that is in multidimensional. At the measure group level, you've got this ignore unrelated dimensions. So if I didn't have this relationship set up here, right, and this was just a gray box between internet sales and currency, multidimensional would have given me that same result set, where it wouldn't have even checked in the conversion rate table, and it would have just given me the same value for every single currency, right? So that actually is ignore unrelated dimensions in tabular, even though you don't specify it. But you might say, well, hold on a minute, Christian. There is a relationship between internet sales and currency. All you have to do is learn a little bit of joining, right? And then you can get from internet sales to date and then just join down to currency rate, and that will get you to currency. So why is that an unrelated dimension? Well, the reason is that data is only propagated through relationships in tabular if the related table is a parent table. So it will only propagate to the one side of a one-to-many relationship, right? So we've got internet sales that will automatically propagate to date, which is, we saw that year was in fact influencing the numbers. It would propagate to customer because customer is on the one side of a one-to-many relationship, right? It would also propagate to product and even subcategory and product category because this has a one-to-many relationship going from here to here, and then another one-to-many going from here to here, and another one-to-many going down to here. So that works fine. It will propagate all the way up to product category fine with no issues. However, when it's trying to propagate this way, it gets to date, everything's good, and then it says, oh, sorry, I can't go any further. I can't join down to currency rate because I wouldn't know which currency rate member you want to aggregate to, or which currency rate row, excuse me, you want to aggregate to, right? So then the relationship stops there, and tabular is therefore making the assumption that internet sales, without any fancy DAX to tell it otherwise, internet sales is not related to currency, which is why the query is acting exactly the same as ignore unrelated dimensions, right? However, as we said, there are some valid business cases that we would want this behavior instead. Right? Well, if I run this query again, where it will only show the value if there's data in the many-to-many mapping table, like the account balance scenario. So how do we do that in DAX? The question is, does DAX support that? Yes, it does. How do we do that? And again, this is an example of, in multidimensional, we're just decorating the metadata of the model and setting up that many-to-many dimension, whereas in tabular, the modeling experience is much simpler, but then we depend on DAX to implement some of those features. All right. So here we've got the measure internet sales sum, and again, I'm using the shorthand notation for the calculate function, and this is overriding the filter context of internet sales sum with the dates that have values in the currency rate table for the current currency in filter context using this summarize function. Just take my word for it, it works. All right. So that's what we're doing there, and this is giving us the default behavior of many-to-many dimensions in multidimensional using this summarize function. Okay. Let's go back to MDX. So the next question is, okay, this is all good, but obviously we need to start applying the conversion rate, right? How do we apply the conversion rate in multidimensional? There's about 3 or 4 different ways you can do it in multidimensional, some better than others. I'm going to start off with just doing it in the MDX query, right? So I want to take the internet sales amount and divide it by the rate to get the converted sales. On the face of it, this looks fine. So this is just for January, and then here I've got United Kingdom pounds with the the US dollars number, then I take the end of day rate and divide the US dollars by that to get this number, which is still displayed as US dollars, but really this is now pounds, British pounds, and it looks okay. The problem with this is that this is not the right granularity that we'd like to apply the conversion at, because we're taking the end of day rate for the whole of January, and if you remember, it's a last non-empty, so it's going to give me the end of day rate for January 31st, but obviously we would like to apply the conversion rate that was actually in place when the transactions took place to get a more accurate number if we sum it up to the month level. So what we'd like to do is apply the calculation down at the day level, take the individual rates that were available for each day, and then sum up the results to get to the month level, right? So to do that, we can run this. This query is just to illustrate the concept I just said. So we're not actually aggregating to the month level yet. We're just having all of the days in January, and we'll take the end of day rate for each individual day that was in place for each day, and then we'll do the converted sales. So these are the correct converted sales numbers for each day in January. If I just paste this into Excel really quickly, and I'm going to put put a sum there and make this nice and big. So this is the number that we would really like for January, right? To apply it at the day level, sum it up for the month. That's what we'd really like for January. So to do that in MDX, we can use the descendants function to go down to the day level, apply the conversion at that level, and then use the sum function to sum up the results. And now for United Kingdom pounds, we get the correct number, which is 1.804 billion, which is a lot more than what is in Adventure Works by default. But again, I stuffed 500 million records into internet sales. Right? So that's the correct number. We're happy it's aggregating correctly at this point. So how would we do that in DAX? Got another query here. So this is just showing me a column for January 2006, and the United Kingdom pounds is 1.804 billion, which is the correct number. So how did we do that in DAX? Well, we're using this SUMX function as an iterator. This is all a little bit alien if you've never done any DAX, and you may have a strong SQL background. This is that filter context, and you've got filter context and row context, which are concepts you need to learn about when you start writing DAX queries. But basically, SUMX, any of these DAX functions with an X on the end are like iterators. They're going to iterate every single record or every single row in a bunch of rows. So it's going to start off with the filter, all of the currency rate values in filter context. It's going to iterate each of those and create its own little kind of private row context, and it will then apply the calculation at the leaf level, right? And it's going to sum up the results. That's what SUMX is going to do, rather than sum, which doesn't do that at the leaf level. All right. You'll notice also that I didn't need to bother with the last non-blank function, because we're iterating each row of currency rate, so there's only one rate available for that row, right? We don't need to do any special logic to get the last rate for out of all the rates in a date period, right? So we don't need to bother with the last non-blank function here. In fact, we don't even need to bother with the sum function here. We do need sum for internet sales amount because there could be multiple transactions for that same day, but we don't need the sum function here because there's only ever one end of day rate for each row, right? So we could even use values here and we'd be guaranteed that it would work okay. So values, if values had more than one currency rate, it would give us an error in this case, but it works fine because there's only ever one currency rate in context when we're iterating each row, all right? Okay. So that's SUMX. Back to MDX. So we're happy that we're applying the calculation correctly now. We're happy that it's aggregating up the date hierarchy correctly. So using the same technique with descendants and sum in MDX, we can create a query like this, and we're happy that these numbers are correct. But the problem we've got now is that all of the values are displayed as US dollars, even for the foreign currencies, which is probably a little bit politically incorrect, right? So what we'd like to do is set the currency values to the correct currency value, and to do that, I'm going to switch over to another cube, the measure expressions cube. When I run this query, we get the correct currency symbols. Right? Not only that, but you'll notice I didn't even bother in this query with that whole sum descendants thing. I'm just using the base measure, and somehow this other cube has already figured out that, okay, well, I want to report that measure by the currency values, and I already know that you want to do that conversion, so I'm going to do that already for you at the leaf level, and you can just use the base measure, and you don't even need to bother applying the calculation. Right? So how did I do that? Again, same pattern, the recurring theme, which is we're decorating the metadata of the model in multidimensional. So in this case, we're using measure expressions. So if I come back over here, and I'll come to the measure expressions project, and if I zoom in right here, you can see that these measures have got these special little function symbols in front of them, right? Because they've got measure expressions defined on them. So if we go to the properties window for each of these measures, you can see there's a measure expression, right, which just takes the internet sales amount and divides it by the end of day rate. And if I zoom in here, you'll see that the measure expressions define the value of the measure and are evaluated at the leaf level before being aggregated, which is exactly the behavior that we want. Right? In fact, measure expressions are the preferred way of doing this type of thing in multidimensional. The reason is that measure expression does do a lot of the work during cube processing, and the queries are going to be faster for large volumes because a lot of the data is pre-calculated, whereas obviously in the query or even in MDX script, even using MDX script cell assignments, you're effectively doing it at runtime. So the recommended approach is to use measure expressions for things like currency conversion or for any leaf level allocations. All right, and if you do use measure expressions, you want to come into the many-to-many relationship here and set the direct slice property to, typically that's going to be the base currency or the default member of all of the attributes of that dimension, or all of the hierarchies of that dimension rather. So this is going to be the member for US dollars, and what this is an optimization that analysis services may choose to use, right? Because it doesn't need to convert US dollars to US dollars, right? You should still populate the conversion rate table with a load of ones so that it divides the US dollar amount by 1 and comes up with US dollars. You should still do that because analysis services is not guaranteed to use this optimization. However, you're giving it the option to use it and not even apply the conversion for the base measure, right? For you to convert US dollar to US dollars. Okay, that's measure expressions. The other thing you noticed was that we've got the correct currency symbols, right? So how did we do that? Well, I've extended the dim currency table in AdventureWorks, and I put in a couple of extra columns, LCID and format string. So I'm using LCID for multidimensional and format string for tabular. And LCID, all of this info is on my blog if you want further info. LCID is a locale ID assigned by Microsoft, and the format string is obviously just the format string for each of the currencies. And then in this project, in the currency dimension, typically you're going to use, for the key column, you might use the surrogate key for that dimension table, and then you'll use the name column. You're just going to have the description. So here it will be the currency name, And then there's this value column as well. And this value column, we're just pointing at LCID, which is kind of like a property bag that we can use to store information about each of the members of that hierarchy. And then in the MDX script, we're using this language function to set the LCID or the language for each of the members of the currency dimension based off the member value, which is going to get the LCID for the current member and populate the language property. That's how you do it in multidimensional. All right, a little bit involved. Tabular is a lot simpler. Here's an equivalent query in tabular. And this shows me exactly the same numbers, and it's using the correct currency symbols. I've got this extra column called the all member column, which I'll discuss in a minute. But basically, we're just using SUMX to do the calculation at the leaf level, just like we were before. And then we're just using the format function to get the format string and apply it to the cell that is coming out in the result set. So as we saw earlier, values will only work when you're using it as a parameter to a function that's expecting a kind of scalar or a single value. It will only work if there's one of those values in filter context, right? And if we were to use this measure, we wouldn't be guaranteed that that is the case. So we put in another wrapper measure on top of it, this one, and this is going to check. If I've got one value in filter context for currency name, then we're good. That means the user has filtered by a particular currency, and we'll just give you back internet sales. We'll give you back this previous measure without doing anything. However, if there are multiple currencies in filter context, that doesn't make sense. We can't sum values of multiple currencies, so we're just going to override that with the default currency of US dollars, right? The most common case that this would happen is if the users drag the hierarchy onto a pivot table, and then the all member in the DAX equivalent, the all member is going to have all of the currencies in filter context. I know that this filter context, I told you in the first session that you need to write some DAX queries to get filter context, but basically, for the all member, if the user drags the hierarchy onto a pivot table, the all member is going to have all of the currencies in filter context. So we need to override that with US dollars. It would also cover the case where the user's gone and selected multiple currencies in Excel, right? US dollars, Brazilian reais, and whatever. So it would say, sorry, that doesn't make sense. I'm just going to give you US dollars, all right? And that works fine. So then down here, you can use the calculate function in your column definitions using the add columns function. So here I'm setting the filter for each of the columns to the respective currency, but then in the all members column, I'm not applying any filter. That's why when it enters here, in this case, for that all member column, it's saying it has one value. No, that's not true. There are multiple values in filter context, so we're going to override it with US dollars, which is why we see the same US dollar amount here in this column as we see over here, right? If we were to not have this wrapper around it, and we were to just use the previous measure down there, where we're not supplying a filter, we would get an error because there'd be multiple, when we get in here, there'd be multiple values in filter context, and it would say, sorry, I don't know which one you want, so I'm going to give you an error. Hopefully that makes sense. So there it says, a table of multiple values was supplied where a single value was expected. Okay. All right. So that's that. We've got 5 minutes left. The other thing I was going to show you was about utility dimensions. Yeah. Okay. Do you want me to talk about MDX scripting versus the equivalent in Tabular, or is that too much to take in at this point? If you need to leave or you need a break ready for the next session, that's absolutely fine. But if you like, I can go ahead and talk about MDX scripting. And the tabular equivalent, which is again is a little bit in depth. Okay, so I understand if you need a break before the next session, but I'll keep going and I'll overrun for about 5 minutes if that's all right. Oh yeah, we got lunch next, right? Lunch follows this session. Okay. All right. So There's a technique in multidimensional called utility dimensions. Right? And what it does is it's a way of organizing your MDX script cell assignments, your scoped assignments, right? In a way that you can reuse that logic for different measures, right? Without having to do the terrible sin, which is copy and paste reuse, right? Now, there is this thing called the business intelligence wizard. I would not recommend that you use this in a production environment because there are issues with it, but it's good for illustrating the concept, okay? So if I was to run this business intelligence, because it uses utility dimensions, right? It just illustrates the concept of utility dimensions. So you can run it, and there's a bunch of different types of enhancements you can choose, including currency conversion. I definitely would not recommend using it for currency conversion. It would create a bunch of MDX script when you should really be doing it with measure expressions. It's going to perform a lot better. But then there's this time intelligence. So you say, okay, I'm interested in calendar hierarchy, and I want to apply it year to date and 12-month moving average. And which measures do I want to apply it to? And you run it through the wizard, and it tells you what it's going to do. It's going to create an extra column in the DSV. It's going to create an extra attribute in the date dimension, and it's going to create all this MDX script. All right, I'm not going to run it because I've already run it, so I can just show you what it did. In the DSV, we have this extra column at the end called calendar date calculations, and if I edit name calculation, you can see this column was created by the business intelligence wizard, and it's just hard-coded to current date. So every single row of this table is just going to have current date in it, right? If I come to the end, you can just see current date, right? Why on earth would we want to do that? Well, let's find out. So then the date dimension, we've got this new attribute, calendar date, nothing particularly special about it. Happens to have is aggregatable equals false, but I won't go there. And then in the MDX script, we can see this attribute. So if you remember, a column in the DSV is going to result, is going to kind of translate to an attribute in the dimension, right? And the distinct values of that column are going to translate to members of that attribute hierarchy, right? So there was only one distinct value, which was current date. So there's only one non-calculated member. There's only one base member of this hierarchy, which is current date. And by default, that's the default member. It's not really doing anything, right? So we're just using this attribute hierarchy as a placeholder in which we can add some calculated members, like these two, which is what the business intelligence wizard did. So then it generated this script. It initializes the calculated members here. And I wouldn't recommend initializing them as strings if you can avoid it, because it explodes the cube space. It's better to initialize it as null if you can. And then it does a scope on the two base measures that we selected in the wizard. So, you know, if you were to use this in a production environment, you wouldn't be using the business intelligence wizard anyway, but you'd be using this technique. Some people would prefer to not have it as, this is effectively utility attributes rather than utility dimensions. Some people would prefer to have a dedicated dimension to create all of these calculated members in rather than just use an attribute of date. But that's okay. But basically you would set all this up, and then you would have your scope here, and you would list all of the base measures that want to reuse that calculation. Okay. So in this case, we're saying, well, both of these measures can be displayed as year-to-date and 12-month moving average, so we'll list them here. This is a very simplified cube. In the real world, we might have 50 measures listed here. And then the whole point is, and even future measures that you add that want to leverage that business logic can just be added to the scope statement very easily, and then they automatically inherit the capability of being displayed as year-to-date and 12-month moving average, right? So then here we have the cell assignments using the aggregate, using periods to date and parallel period, and then we end the scope there. And then, for some kind of power users, they can get their head around this calendar date calculations thing, but most users won't get that. So what you end up doing is you end up exposing the measure as just a regular calculated measure. So here we've got year-to-date internet sales amount. So then here we just list the base measure, and we specify a tuple or tuple or whatever, and we specify the year-to-date calculated member in here, and now automatically anytime any of these measures want to be displayed as year-to-date, that's all we have to do. We don't need to copy and paste that logic for every measure, right? So that's the whole point of utility dimensions, is to just avoid the copy and paste reuse. However, that's a lot of work just to avoid a little bit of copy and paste reuse, right? That's a lot of complexity. Go ahead. Yeah, so a lot of client browsers, I think even I think even Excel's had issues with this. They can't use this attribute hierarchy and then slice it by the calculated members very well. But exposing it as just a calculated measure, then it acts like any other calculated measure. But you're right, there are issues with the client browsers. So it's a very sophisticated technique. There are some quirks associated with it. And it's a lot of work to do just to avoid a couple of lines of copy and paste. but that's the beauty of MDX scripting, right? This is like what it's all about. Oh well, I'm gonna spend 3 days avoiding a copy and paste that I could have done in 3 seconds, right? So doesn't make much sense from that perspective. And then,
well, it's a bigger enterprise perspective. You're
right.
doing a lot of copy pasting and a lot of maintenance.
You're right. I've got some MDX script that I've done which is just huge, right? And for them, when you've got like 100 base measures, and each of those can be displayed in 5 different flavors, it is definitely the way to go for multidimensional. Tabular, we haven't got that option, right? So we end up just having to copy and paste it. But you could argue that it's somewhat more supportable that way. So if I go to obviously this is a very simplified example, so it makes it look as though, why don't I just always copy and paste it? But as Bob said, there are cases in an enterprise setup where having MDX script set assignments and utility dimensions are going to help you a lot in very sophisticated calculation scenarios. So here we have year-to-date in DAX, and we have got this year-to-date function, and over here we've copied and pasted the year-to-date function for 2 measures. All right. So really that's it. That's the comparison between the two. The other thing to notice is here when we're doing these are our DAX calculations that are built into the tabular model. So over here I was creating them in my query, but it's exactly the same syntax, within the measure definition. I could have copied and pasted each of these measures into one of these measures that are stored in the tabular model for reusability. But obviously this interface is a little bit quirky. It might be okay for Power Pivot users who are used to Excel, but for an enterprise situation you'd probably prefer to not use this. So there is a tool called the DAX editor that kind of extracts all the measure definitions and puts it in something a bit more like a script. And there's some limited IntelliSense that works here, and then you can define all your measures in here and just import them back into the tabular model. Okay. Rather than having to create them here. So those are that's in a nutshell, the complexity of MDX scripting and the kind of sophisticated techniques that we would use in MDX. Tabular is much simpler, but it's not as elegant. And there may be some challenges in terms of in an enterprise scenario where you really do have a lot of calculations that can be reused. You can definitely refer to another measure. You can reuse another measure in your calculation by just referring to it, but you can't reuse the actual calculation itself, right? So you can't have a scope that does a year-to-date calculation and then just reuse that business logic across different measures, right? So yeah, again, it's kind of 6 of one and half dozen of the other. I think Microsoft just received a lot of feedback that MDX was too much of a leap, and it wasn't good for the proliferation of Microsoft BI. So that's the way they've decided to go. All right, so just the last couple of minutes, I'll go back here. We've already seen this slide in part 1, right? So I guess I don't really need to cover this. This is all the stuff. The only stuff I'm going to cover here is the stuff that we actually saw in the demo, right? So we saw that we couldn't get rid of the all member, right? So here in the DAX query, if I go to the currency hierarchy, I've still got this all member that I can't get rid of, which is what that's what I was dealing with when I was checking whether all the currencies were in filter context, because I couldn't get rid of it. Whereas in the MDX version, this is exactly the same hierarchy that the users would see in Excel, obviously. I don't have the all member, right? So again, I couldn't get rid of it. I did that in the properties. No, it was is aggregatable equals false, and then I had to set the default member as well. There is if you've got a hierarchy in that has like repeated members in some cases and not in others, there is an option to kind of not show the repeated member. Yeah, and you know that kind of relates to how tabular deals with parent-child hierarchies, but I won't go there right now because that's another topic. But so yeah, you're right. There are these other that is another thing that I didn't list here that is not supported in tabular, which is again decorating the metadata of the model. So we saw couldn't get rid of the all member, couldn't specify a non-standard default member. In this case, I wanted to specify US dollars as the default member, but the most common use case for this is for the date dimension. When the users drag on internet sales onto a pivot table and they don't even know that a novice user hasn't even conceptualized that there even is a date dimension, it just shows them internet sales for the whole cube or tabular model, which isn't very intuitive, whereas you can have the default member be the current year or the current month, whatever, which is a bit more intuitive. Ignore unrelated dimensions. We saw we can't set this in the tabular model designer, but we kind of inherit it for free from multidimensional, but we just can't change it to ignore unrelated dimensions so that it shows nulls, right, rather than just repeating the value. And then that's it. And these are all the other features which we're kind of out of time, and I covered these in the first session anyway. Some of these may be showstoppers, but by and large, there are generally workarounds for what is not in tabular that is in multidimensional. There are a few that there are not workarounds down in this area over here, but they are pretty niche areas, right? And most of the time you should be fine, but obviously if you really need translations or you really need WritePack, then tabular may not be an option for you, right? We had that whole discussion earlier that if you've got an existing cube, say in 2008, and you want to migrate it to 2012, if it's working fine, don't bother migrating it to tabular. If you're having performance issues, maybe prototype something in tabular, make sure it's going to work for you, and then think about migrating it to tabular. But don't just migrate it for the sake of it. However, if you're starting a brand new project and you want to use the next generation of in-memory analytics, which is where the infancy of the whole thing, then definitely consider tabular, but just make sure you don't really need any of these features over here. All right, and I'm sure that tabular is going to be enhanced in the future to include a lot of these features. It's early days. Okay, these are the two books. So I gave out one of these books earlier. Both of these books refer to BISM Normalizer, which you saw earlier, which I'm quite proud of. These are the two leading books on Analysis Services 2012. Resources, BISM Normalizer. These are just like tools that you install in your development environment. BISM Normalizer. BIDS Helper is going to give you your custom drill through and a bunch of other features, especially for multidimensional. DAX Editor, we saw that. DAX Editor gives you more of a script view of your DAX measures in Visual Studio. I was writing my queries in Management Studio. There was no IntelliSense or anything like that. Obviously, that will come in a later release. But in the meantime, if you really want that, you can use this DAX Studio, which is an add-in for Excel, which works nicely with Power Pivot. But you can set it to look at a Analysis Services tabular model on a server, and that's going to give you more IntelliSense type of thing for query authoring. That's my blog. Pretty much everything I've covered in both sessions is on my blog. And there's hundreds of other good blogs out there on analysis services, MDX, and DAX. Obviously, I can't list them all here. The only one I'm going to list is Chris Webb's, which has been probably the leading blog on analysis services, MDX, and DAX for the past 3 or 4 years. Okay, that's it. So thank you very much, everyone, for attending this session. Hopefully, you got something out of it, and hopefully, it wasn't too much out there in the multidimensional, world. And I'm sure a lot of these concepts you're going to pick up in more detail when you start using the product. So thank you very much. All right. Thank you. Thank you.